This video, we are going to talk about the setup of uniform distribution, and then after that, I am going to give you a comprehensive example, which is one example followed by a bunch of probability questions. Let's start. So for uniform distribution, when you read the uniform distribution problem, the problem is usually very short and simple. So all you have to do is you have to grab two numbers from the problem, which is a minimum and a maximum. So in general, the minimum I call it an A, the maximum I call it a B, and then the probability density function, very simple, is 1 divided by B minus A. Is always, listen to me, the uniform distribution, the probability distribution function is always 1 divided by maximum minus minimum. So we have the probability distribution function, we call it a PDF, so that is f of x equals to 1 divided by b minus a, and then the x is a random variable, f is the name of the function. So if you don't know what function is, you have to watch the previous video. Alright, so in the previous video, I clearly explained the difference between the function and the equation. So A is the minimum, B is the maximum. That is the two numbers that you have to grab from the problem. And then using notation, we write that. So we call x is a random variable. This little curve means follows. So x follows uniform distribution with minimum A and maximum B. So the PDF has two other names. So the first name that I use in my other classes is probability density function. It's also called PDF. So they changed the word distribution to density. They mean the same thing. In some textbook, they call this probability mass function, PMF. So f of x is equals to 1 divided by b minus a, right? There is no x on the right hand side of the function. So b is a constant value, which is a number. A is a constant value, which is a number. So 1 divided by b minus a, then you get a fraction. So let's say b equals to 12, and then a is equals to 2, then 1 divided by b minus a, which is 1 over 10. So that is a constant value. It is not changing at all. So we have f of x equals to 1 over 10. That is there is no x, so there is a no slope. Then the graph of this f of x equals to 1 over 10 is a horizontal line. All right, so that's why we have this graph. So we have an x-axis and a y-axis. So the y, we don't call that a y anymore, we call that a f of x. So we have on the x-axis, we have a cut at A and a cut at B, and then the height is 1 divided by b minus a. So when x is equals to a, we have a point at 1 divided by b minus a. At x equals to b, we have a point at 1 divided by b minus a. So there are 2 points, and then we draw a line to connect these 2 points. So the line, do you see there is a pink horizontal line? This pink horizontal line is the graph of the probability distribution function of uniform distribution. So this is just look like a rectangle, right? So when I say uniform distribution, no, so now I'm trying to say this word to you. Uniform distribution, one image that should pop up in your mind is a rectangle. Again, let's do this. Uniform distribution. You should create a rectangle in your mind. So there are 2 cuts. One cuts at A and then one cuts at B. So you can call it the minimum and the maximum. And then the graph, the picture of 1 divided by b minus a is a horizontal line. So starting at A and then ends at B. And then how tall is this rectangle? The height of this rectangle is 1 divided by b minus a. And then the domain means the place where x lives. So the domain, do you see the yellow word, the domain? So x is between a and b. I don't care when x is less than a. I don't care when x is greater than b. I only care the stuff between a and b. So the area under this line, how do you find the area of a rectangle? You use the base times height, right? So the base is b minus a, and then the height is the probability density function. So if you take a look at that algebra, so the base times height is just equal to 1. So do you remember that back in the discrete random variable, we have a table, right? So x has a distinct values, and then each distinct value has a corresponding probability, and all the probabilities add up to 1, right? So that is for discrete random variable. How come there is no table in here? Because in this problem, x is a continuous random variable, so there is no more table. I cannot break down the x into many rows. That cannot be done anymore because x is now any value between a and b. So I cannot give you a table anymore. So instead of giving you a table, then what is the table right here? So that in a discrete random variable, we have a table. So discrete random variable, a general discrete random variable, we have a table. For the binomial distribution, we have a table. How come there is no table in here? The table is already on this page. Where is the table? The table is the graph. So the graph is the table. So in the table, the sum of all the probabilities equals to 1, right? So in this graph, the area under the straight line is equal to 1. So the graph works just like the table. Since x, we cannot break down x into this a number of distinct values, so I cannot draw a table anymore. So x is any value between a and b, then I have to give you a picture. So the total area is equals to 1. Look at the blue, just like the sum of all the probabilities of a discrete random variable. So how do you find the expected value, variance, and standard deviation of a uniform distribution? So this is how we do it, and remember, this set of formula is for uniform distribution only. So if you are talking about some other types of distribution, then this set of formula is not applied. So these three, line 1, line 2, line 3, expected value, variance, and standard deviation, they are for uniform distribution only. So for the expected value, we have the expected value equals to 1/2 times a plus b, that is always a 1/2, and then the variance is 1/12, always 1/12, it doesn't matter what problem you are solving, times b minus a square, and the standard deviation is the square root of variance, and the 1/12 is built in the formula. The 1/2, the 1/12, you cannot change those two numbers. They are built in, right? You cannot change them. And then before we move on to a probability question, I would like you to take a look at these commonly adverb and phrases in statistics. So this one, we already mentioned that in a discrete random variable many times. For the at most is the maximum is n, including n itself. So we have x less than or equal to n, and the at least is minimum is n. So we have x greater than or equal to n, the at most and the at least, they both include the n itself. So for the inequality symbol, we have to use an equal. For the more than and the less than, they are pretty straightforward and self-explanatory. So they do not include n. More than n is just x greater than n. Less than n is x less than n. No equal at all. And the no more than is the same thing as at most. No less than is the same thing as at least, right? So no more than, this is supposed to be a more than. So if you put a no in front of it, so the opposite of more than is less than or equal to. So if you do a no less than, the opposite of less than is greater than or equal to. That's how I interpret these two symbols. And then between A and B, we have an inclusive. Inclusive means we have an equal. Exclusive means we do not have a equal. All right, so every time we solve probability questions in statistics, you will see these adverb and phrases a lot. Now, finally, let's move on to our first uniform distribution example. So suppose a multiple choice question can be answered in 60 seconds. The time follows uniform distribution. The problem is just that simple. So you have two sentences. The time follows uniform distribution. So all you have to do is you have to pick up the minimum, you have to pick up the maximum in 60 seconds. That means A is equals to 0, minimum, and then B is equals to 60. The maximum is 60 seconds, the minimum is 0 seconds. And then you have to do part A, set up the probability density function. So the setup is you have f of x equals to 1 divided by b minus a. So that is 1 divided by 60 minus 0. So the probability distribution function or density function is 1 divided by 60. So this is your PDF. So we have f of x equals to 1 divided by 60, and then the domain is that x is between 0 and 60. Anything else? We need a graph, right? Okay, so let's draw a graph. So the graph, this is my y-axis, and then this is my x-axis. And then we have a 0, and then we have a 60, And then the height of the rectangle is the PDF, that is 1 divided by 60. So we have a point at 0, we have a point at 60, right? So we have to draw a horizontal line to link these 2 points, and then the cut one at 0, and then the other cut at 60. So that is my x-axis, and that is my f of x. So this works just like the table of a discrete random variable. What is the area under the horizontal line? So by the way, how come this is a horizontal line? Because this PDF is y equals to 1 over 60. Y is always equals to 1 over 60. It's not changing, so the y value is not going up or not going down. So the slope is equals to 0. So we have a horizontal line. The slope is equals to 0. If you don't understand this, that means you haven't watched the previous part. I suggest you to do that right now if you don't understand what the slope is at all, or if you don't remember the slope from your algebra class. So since the graph, we will be using this many times, so allow me to do a copy. So I am going to copy this. I'm going to copy that, so when I solve a problem, I can just bring it back. I don't need to sketch this every single time. Okay, so did I do everything? No, not yet. I have to verify the probability distribution within the domain is valid. So let's do it. So what's the area? So the area is the base, which is 60 minus 0, times height, which is the PDF, so 60 times 1 over 60, that is equals to 1, so we know the area is equals to 1. That works again, that works just like the table of a discrete random variable. The area of all the probabilities equals to 1 in a continuous random variable. The total area under the graph is equals to 1. So that is done for part A. So the yellow is for part A, and then we switch another color for part B. Part B is the expected value, variance, and standard deviation. So the expected value is equals to 1/2, and then A plus B, right? A plus B, so that is 1/2, 0 plus 60, so that equals to 30 seconds, right? So that means on average, students use 30 seconds to answer a quiz question. And then the variance is 1 over 12, and then b minus a squared, so you have a 1 over 12, 60 minus a 0 squared, so you have a 60 squared, so that is a 3600, right? And then divided by 12, so that is equals to 300, and then this is in second square. I know second square is meaningless, so that's why we need a standard deviation. Let's do that down there. So the standard deviation is the square root of 300, so the square root of 300 is equals to, you round that to 1 decimal place, so that is around 17.3 seconds. So my best guess is students spend 30 seconds to do answer a question, and then more or less by 17.3. So you plus or minus 17.3 to create interval estimate. All right. So that means you will get a lower limit, right, and an upper limit. So that means our best guess is students need around that and that many seconds to answer a quiz question. So you take the 30 minus 17.3 to get the lower limit. You take the 30 plus the 17.3 to get the upper limit. So that math is so easy, I will just leave that to you. So using this, we will be answer a bunch of probability questions. So first of all, let me make this bigger so that it's easier for you to read. So that in the next question, in part C, what I wanted to do is I want to find the probability that the quiz question can be answered in at most. At most means no more than 27 seconds. So at most. So C, pop up at most, so that will be x less than or equal to 27. And then what you have to do first is you have to sketch the graph. So the graph, I got the graph right here. Let me just move this over here. Actually, I can do that. Make the graph smaller so I can save some space. So copy this for the next problem. So where is 27? 27 is around here, right? And then less than or equal to. So this is the area that we are looking for. So now we are start dealing with graphs. So when you use a graph, the probability is the same as area. So I am asking, what is the area of this square or rectangle? So that is the base, which is 27 minus 0. Remember, always big minus small because probability cannot be negative. And then you multiply the height. So 27 divided by 60 is your answer. So this is an acceptable answer, 27 divided by 60. So if you are asked to approximate this, then you have to use 27 divided by 60 and then provide an approximation. So this one, you don't need to round to 4 decimal places. It's equals to 0.45 exactly. So this is your answer. So that would be your part C. And then part D, let's switch color for every problem. So in part D, what I am asking is, I am asking at least 45. So probability x is greater than or equal to 45. And then let's paste the graph. So I don't need to draw a new graph. So this is my graph. And then you have to tell me where is 45. So that should be close to 60, right? Greater than or equal to is right there. So you have a big minus small. And then times the height of the rectangle. So this is a 60. And that is a 15, right? So 15 divided by 60 is your answer. And then on your calculator, you take a 15 divided by 60, you will get 0.25 exactly. So that is the answer that you have to provide. So that is part D. And then part E. So as we move down, you won't see the problem anymore. So now is a good time to take a screenshot so you can follow around without rewinding the video back to this place. So did you get your screenshot? Okay, moving on to part E. So part E, they are asking more than 25. So more than, let me give you a more than. So more than is just x greater than 25. And then the first thing that we have to do is you have to draw a picture. So I use technology and you are not. So you have to draw this yourself. And then where is 25? 25 is like right here, right? So 25 is like right here, more than. Then we have to capture all these areas. Then the probability is big minus small times the height. So you have 60 minus 25. That equals to 35. Divided by 60, so that would be a little bit more than 0.5, right? So that is around 0.5833. You take 35 divided by 60. This one, you do have to round. So that is part E, and then part F is less than 34 seconds. So part F is less than 34, so part F is probability x less than 34. So let me draw the graph, which means I paste the graph, but you have to sketch that yourself if you are using paper. So 34 is around here. So 34, and then I shade the area that I am interested in. So what's the area of this box or rectangle, whatever you like to call? That equals to big minus small times the height. So that is equals to 34 divided by 60. So should be the approximation should be close to the previous answer, right? 34 divided by that. So you have 0.5, a bunch of 6. So that will be 0.5667. So that is the answer to F. And then the last one is part G. Part G is between 20 and 40 seconds. So switch another color for part G. Between, so part G, so that will be x. Probability that x is between 20 and 40 seconds. My next question is, should I use the equal? I will answer that in a minute. So we paste that. So 20 is here. And then 40 is there. I am looking for this probability. So the probability is big minus small times 1 divided by 60. So that will be a 20 divided by 60. So that will be a 1/3, right? So 20 divided by 60, that is 1/3, which is around 0.3333. So is this important? The answer is no, that is not important. Why? Because x is a continuous random variable. Think about this. If you don't use 20 and 40, what number do you use? 20.1, I can argue that with you. So if you use 20.1, I can argue with you and saying, okay, I can use 20.001, and then your friend can argue with me and say, all right, you are wrong. I can use 20.0000001. All right, because this is the thing. So if you don't use 20, there is no other number that you can use. So you have to use 20 and 14 regardless the equal. So in the previous problem, so if you take a look at part E and part F, so the answers remains the same even though you draw an equal right next to the 25, right next to the 34. Even though you put an equal in there, that changes nothing because x is a continuous random variable. For discrete random variable, that changes everything. All right. So that will be all in this part. This is not the end of the problem yet, because in the next video, I will show you how to answer conditional probability in this type of problem. So that requires a little bit more skills. So we will divide that into another video. So in the comment section below, let me know what you think. Do you think this is helpful? Let me know. If you think that is helpful, you really like it, please click the like, subscribe, share this video out for me. I'm sure many people are learning this right now. I appreciate your help a lot. So I will see you all in the next lesson. Signing out for now.